Hello everyone, today we are starting with Unit 7. So for today, we have a mechanical device is used to launch a potato vertically in the air. The potato is launched from a platform of 20 feet above the ground. So that's going to be some important information. 20 feet above the ground. With an initial vertical velocity of 92 feet per second. The function h of t equals negative 16t squared plus 92t plus 20 models the height of the potato over the ground in feet t seconds after launch. Here's the graph representing the function. So we have our graph over here. You can see we have height labeled on this side and time labeled down here. So for each question, we want to be prepared to explain our reasoning. What is the height of the potato 1 second after the launch? So we can look at 1, go up on our graph and see that point is right here. So we need to make sure we understand our scale. So we have 0 down here, then a tick mark, and then 40. So that means this tick mark has to be 20. So this would be 60. This would be 100. So that is the height of the potato after 1 second. So we could say 100 feet. Number 2, 8 seconds after the launch, will the potato still be in the air? So if we follow this path, it starts at that 20 off the ground, goes up, comes back down, and this is at 6 seconds. And then 8 seconds is all the way over here. This bottom part here is representing the ground. So the potato can't go through the ground. So will the potato still be in the air? No. It will not, because this is the point when the potato hits the ground. So it is no longer in the air. Will the potato reach 120 feet? If so, when will it happen? So we're looking at 120 feet over here. We can look across and see, does our graph touch that height? Yes, it does at these 2 points. So we can say yes. And then we can look at our graph and look down at the x-axis to see what those times are. So that's about 1.5 seconds. And this one is a little sooner, so maybe 4.25 seconds. Somewhere around there. We know it's between 1 and 2 and somewhere between 4 and 5. And if you want to say like 4.3 or something like that, that is also fine. And then last question, when will the potato hit the ground? Whenever we see something like that, we're looking at when is my height 0. So height is 0 right here on that x-axis, and we can see that it hits the ground there at 6 seconds. Okay. Example 1, we have the flying potato again. So we're talking about that same equation. Okay, negative 16t squared plus 80t plus 64. Okay, this is our equation for this situation. And our first question says, what equation would we solve to find the time? Since we're finding the time, we're looking for a value of t at which the potato hits the ground. So what is the height when something is on the ground? The height is 0. So that means this is my output. So we need to plug that in for the output of our equation. So all we're asking here is to find the height, or find the time, the equation for when the potato hits the ground. So we would just say 0 equals negative 16t squared plus 80t plus 64. So to find this height, we can look at plugging in some different values for t. So I'm going to go ahead and do that on the calculator. We're just looking for any values of t that we could plug in to see how close we can get to 0. So we have our equation, and we're just going to plug in some different values of t. So I'm going to start, I don't know, by picking 3, maybe. Okay, we're just going to see where that puts us. Then we have plus 80 times 3 plus 64. So that gives me a height of 160, and we're trying to get that height to be 0. So if we go up and highlight the equation and hit enter, it will copy it down. So let's try 4 and see what happens. 128. So this is lower, which means my potato is getting closer to the ground. So let's try 5. 64. So now we're even closer. Let's try 6 and see what that gives us. Negative 32. So because we go from 64 feet at 5 seconds to negative 32 at 6 seconds, we know we hit the ground somewhere between 5 and 6 seconds. So let's just try 5.5 to see what that gives us. We're at 20. So we're pretty close. If you want to keep trying other decimals, you can, but we're just trying to look to get as close to 0 for that output as we possibly can. So we could say for our answer, between 5.5 and 6 seconds. Okay, right now we're just trying to estimate and get as close as we can. Example 2, we have the expressions p times 200 minus 5p and negative 5p squared plus 200p to find the same function. The function models the revenue a school would earn from selling raffle tickets at p dollars each. At what price or prices would the school collect $0 in revenue from raffle sales? So again, we are taking that equation. You can use either one. If we have negative 5p squared plus 200p, we are setting that equal to 0. So we just want to try to plug in some different values for p to see when do we get 0. So the first one that we could try, or that you could guess, is if we sold the tickets for nothing, right, we wouldn't make any money. So negative 5 times 0 squared plus 200 times 0 does give us 0, right? If we're not selling them for anything, we're not going to make any money. But there's also going to be a maximum price where people won't buy them. Okay, so we could sell the tickets for too much money, no one would buy them. So maybe I'm just going to guess, let's try $15 and see where that puts us. So I'm just plugging in 15 for both of those values. 1,875. So that means we'll make a profit or revenue. We'll make the revenue of $1,875. So that is good, right? We want to get down to 0. So maybe let's try 20. What does that do? Now we're at 2,000. So we're still going up. So that means my number needs to get even larger because we're still increasing. Okay? So I don't know, let's try 30, see what that does. 1,500, so now we're coming back down. Let's try 40. Okay, so I'm just guessing and checking some values and looking at how those output values change. Okay, so now we're back down at 0. So if I sell the tickets for $40, we would also not make any revenue in that case because they would be too expensive. So our answers would be $0 and $40, okay? $0 would be not enough money and $40 would be too much money. The school staff noticed that there are 2 ticket prices that would both result in a revenue of $500. How would you find out what those 2 prices are? So we don't need to technically figure out what those are right now. We just want to talk about how could we find out what those prices are. So there's 2 ways that we could do it. We could take those equations that we have, p times 200 minus 5p And our other equation, negative 5p squared plus 200p, right? That's the same equation, just written differently. And similarly to how we set that equal to 0, we could set that equal to 500 and just try some different numbers and figure out when will we see 500. The other way is we could graph and look for a y value of 500, right? Those are the only two ways we know right now, is just trying some different values into our function or graphing. So as we go through this unit, we'll talk about some different ways that we could find the answers to these questions. Hello everyone. Today we are going to start looking at solving some of these quadratic equations. So if we look at our warm-up here, we want to know how many solutions does each equation have and what are they? So if we're looking at this first equation here, we have x squared equals 9. So we're kind of thinking, what can I multiply together to give me 9? And it has to be the same number. So we could have 3 times 3 to give me 9, or we could also have negative 3 times negative 3 to give me 9. So that means my answers here would be x equals 3 and negative 3. So I would have both of those numbers as solutions. For number 2, we're looking for two things that we can multiply. A number that's the same, we can multiply by itself to give us 0. So here there's only one option. The only way to get 0 is if we do 0 times 0. So here x has to equal 0, okay? And that's because we're talking about x squared, okay? So remember, x squared is x times x, so we have to be using the same number in both of those places. That's why we can only do 0 times 0, okay? Number 3, we have x minus 1 equals 3, or x squared minus 1 equals 3. Well, if I move this 1 over to the other side, we would add it. So really what we're doing is saying x squared equals 4. Well, how can I get 4 if I multiply a number by itself? We could do 2 times 2 or negative 2 times 2. So here x could equal 2 or negative 2. Okay? For number 4, again, we can kind of think about 2 times something squared gives me 50. If we want to get rid of that 2, we could divide by 2. Then we have x squared equals 25. Well, what number times itself gives us 25? 5 times 5, or negative 5 times negative 5. So that means x equals 5 or negative 5. Okay? Now for number 5, we still have two things being multiplied together, but we have the first thing is x plus 1, and the second thing is x plus 1. So that means I want those parentheses to give me 0. So the only way to get these whole parentheses to be 0 is if x is negative 1. Negative 1 plus 1 gives me 0. Negative 1 plus 1 equals 0. 0 times 0 gives me 0. Okay, so here x has to equal negative 1. All right? And we'll get into solving these a little bit more and like where these are coming from. Okay, so if you want to try 6 and 7, go ahead. I'll give you the answers, but we're going to talk about solving them in the next couple of days. So number 6, x either equals 0 or 6. And number 7, x equals negative 1 or 3. Okay, so don't worry too much about these right now. But if you did try them and found those answers, that's what they would be. Okay? One thing I do want to talk about, if you could make a note on the side of your paper, is there are 3 different types of solutions we could have in terms of a quadratic, okay? Some of them we've already seen, like with number 5 here, we only had one number, x equals negative 1. So if we were thinking about that in terms of a graph, we would have negative 1 right here, and my graph would just touch that point, and then go up. So we would have only one x-intercept, which means we would have one solution. Okay, in this case, it would be -1. The other option we could have, like we did with a couple of these, was two numbers. So for number 1, we had 3 and -3, or number 3, we had 2, -2, 5, -5, those types of things. So if you have two solutions, your graph would hit the x-axis twice. Okay, and it could open up or down, but you would have two x-intercepts, meaning you have two solutions. And then lastly, just as we've had in units past, we could have no solution as well, which just means we don't touch the x-axis at all, and that would be no solution. So those are our three options and what they would look like in terms of a graph, which again, we'll be talking about a lot more throughout this unit. Okay, so we're gonna go through now actually solving these and finding the solutions. So what we wanna do is look in our equation and we need to isolate our variable just like we did back in unit 2. So here my variable is n and it has that power of 2. So that is what we want to isolate first. So that means I need to get rid of the +4. If you like, you can draw the line through your equal sign. And how do I cancel +4? We would -4. Those will cancel on the left, and I can subtract 4 on this side. So now I have n squared equals 400. All right, now for us to be able to solve this, we need to get rid of this power of 2. Okay, we have to get rid of this little exponent here. And the way that we do that is by taking the square root. So that's going to look like this on both sides. That square root is going to cancel the power of 2. So that way on this left side, we only have n left over. But what we do to one side, we have to do to the other. So I'm going to square root 400 as well. Okay, and we can go ahead and use our calculator for that. So on our calculator, we are going to, let me make that a little bit bigger. Okay. Oops. We are going to use our square root button, which is right over here on that square button that we used last unit. So right here, it's in blue. So we're gonna have to hit our second key and then press this button here. So we're gonna hit second, and then that square root key, and then type in 400 and hit enter. So that gives me 20, okay? Now your calculator is only going to give you the positive answer, okay? So we know 20 times 20 equals 400, but we are going to be responsible for coming up with the negative as well. So we need to know that we also need -20 times -20 because that also gives us 400 as an answer. So that means my two answers here would be 20 and -20. Okay. If we look at number 2, we can draw that line in. Again, we have to get n squared alone, so we need to get rid of this 3, which is being multiplied to n squared. So I'm going to divide both sides by 3. Okay, we can go ahead and use our calculator here. And we have 432 divided by 3. That gives me 144. So I have 144 equals n squared. Now we are at that point again to take the square root of both sides. The square root will cancel the square on the right. So we just have n, which is what we want. We can go back to our calculator and do square root. 144 gives me 12. So we have 12 and -12. We have to write down the positive and the negative for that answer. Okay? Now, if we're looking at number 3 is slightly different because our variable is inside our parentheses here, but the whole thing here is being squared. So what we really need to do is isolate whatever is being raised to the power of 2. So this is what's being squared. There's nothing else outside of it. So we can just go ahead and start with square rooting to get rid of these parentheses here. That way I can get to that variable. Okay, so we're going to square root both sides. And we know the square root of 144 is 12 and negative 12. We just got that from number 2. So what's going to happen, because we still have an expression here, we are going to get 2 equations. We're either going to get n plus 1 equals 12, or we have n plus 1 equals negative 12, okay? Now these are just one-step equations that I can solve. So we can subtract 1 to cancel. So we either get n equals 11, or the other side we're going to subtract 1 as well. But now we have negative 12 minus 1, which gives us negative 13. So those are my 2 answers. So we are trying to isolate whatever is being squared. In those first 2 examples, it was the variable, right? We had n squared for both of those, so that's what we were trying to get alone. Here it was the whole expression. So you can always go through with a highlighter and highlight whatever you're trying to isolate. And that's exactly what I'm going to do for number 4. So we want to look at what is being squared. N minus 5 is what's being squared, okay? That means that's what I need to isolate. So I'm going to draw that line down the equal sign. First, I need to get rid of this 30, then we can square root to get rid of the square. So first, we can add 30. That will cancel there. Add 30 on the right side. So now I have n minus 5 squared equals 100. Now that I have what's being squared by itself, we can square root to cancel that power of 2. And then we can square root the 100 as well. Bring my calculator back down here. And we can go ahead and enter square root 100 equals 10. Okay, now we do have this expression here. So we know that we either get n minus 5 equals 10, or n minus 5 equals negative 10. We still need that positive and negative. Don't forget that part. So to solve this, we would add 5. So n equals 15. That's my first answer. Or solve the same way over here, plus 5, but now we have n equals negative 5. Okay, because here we had 10 plus 5, which is 15. Here we have negative 5 plus 10, which is negative 5. So be very careful when you're solving these. It can be a little tricky, all right? So that is how we solve those with our square roots. And that is it for today, so make sure to write down any questions that you have, and we'll be doing more of this in our next lesson as well. Good morning, everybody. Today we are going to be talking about simplifying radicals. Okay, a radical is just a square root. Okay, that's what we're going to be working with. So for a radical, we are talking about square roots. Okay, so you may have seen this before, you may not, but we're going to review it, okay? So first we're going to start with reviewing some squares of numbers. So for example, if I take 1 squared, remember that means 1 times 1, which is 1. 2 squared, we have 2 times 2, which is 4. 3 squared, we have 3 times 3, which is 9. 4 squared gives us 16. 5 squared is 25, and so on. So I'd like you guys to pause the video, finish the rest of these, and then you can continue playing to check your answers. And feel free to use a calculator if you'd like, especially for some of those bigger numbers. All right, so we should have 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Okay? So we are going to talk about simplifying square roots. So there are two ways to do this, okay? All of our numbers up here, we call them perfect squares, okay? Because if I take for example, let's look at 12. If I take the square root of 144, that is 12. We're essentially asking, what number do I have to multiply by itself to get to 144? That answer would be 12, okay? And this button is on your calculator as well. I will show you how to do that. So on your calculator, if you wanted to do the square root of 144, you would hit your second key, and then the button we've been using to get the power of 2, that'll give you the square root. You can put in your number and then hit enter, so we can see the square root of 144 is 12. Okay, so when we are looking down here to simplify square roots, you can use your calculator if you'd like. Okay, so on your calculator, if you type in the square root of 16, that will give you 4. Okay, if you know that 4 squared is 16, we can also use that fact. Okay, that's one way to do it, is just using your calculator. Okay, now that doesn't always work. Okay, and what I mean by that is we don't always get a nice number. Okay, so what I'm going to show you with all of these is how to break them down mathematically by hand, which is what we'll have to do for simplifying if it doesn't work. Okay, so feel free to try on your calculator, check the square roots first, and if you get a decimal, which I will show you, we'll have to break it down like I'm going to show you now. Okay, so let's actually, I actually want to start with number 5 here. Okay, the square root of 30. So if we try that in our calculator, I'm going to do second, that power of 2 button, and 30, and that gives me 5.477. Okay, so that's what we don't want. We do not want decimals. It has to be a nice number. If it gets decimals, then we need to simplify. So the way we're going to simplify is use our prime numbers. So the prime numbers we're going to look at are 2, 3, 5, 7, 11, and 13. Of course, there are more, but we really won't be needing them, okay? So what you're going to do to simplify this is always start with 2. We are always going to start with 2. It just will make things simpler down the line. So we're going to look at our number 30 here and ask ourselves, can we divide 30 by 2? If we can, we're going to list that other factor on the other side. So 30 divided by 2 gives us 15. So our goal is to end up with prime numbers at the edge of all of these little branches, okay? So now we're working with 15 because 15 is not a prime number. So we say, can 15 be divided by 2? Nicely, meaning no decimals. It cannot, so that means we're going to move on and say, okay, can 15 be divided by 3? Yes, it can. So now we have, 3. And what is 15 divided by 3? That is 5. Okay, so if you'd like to use a highlighter or a pen or something to circle or mark off when you have a prime number, feel free to do so. So we know that 2 is prime. 3 is also in my list of primes, so I can highlight that one, and so is 5. So all of these numbers at the end of my trees here are prime numbers, okay? Now, we need to have a pair of numbers to simplify this square root, okay? And I'll go into why that is later, okay, a little bit more. So let's see, if we look at Let's talk about 25 really quick. So write this on the side just as an example. If we have the square root of 25, 25 is not divisible by 2 or 3, but it is divisible by 5. So we have 5 and 5. Because we have a pair of 5s, that means I get 1 5 that is not inside my square root, okay? Because essentially the square root is canceling out that power of 2. So if I had the square root of 5 squared, the square root cancels the power of 2, so all we're left with is 1 5, okay? So because we don't have any other 2s, I don't have any other 3s, and I don't have any other 5s, there's no other way for me to be able to simplify this square root of 30, so we would just have to leave it as the square root of 30, okay? So now that we've kind of looked at that, let's go back to the square root of 16. Again, we're going to do this by hand to reinforce that idea. So we have all of our primes. I'll list them again here. 2, 3, 5, 7, 11, 13. So we start with 16. Can that be divided by 2? Yes, that gives me 8. So here's my first prime number. Now we're working off of 8. Can 8 be divided by 2? Yes, it can, and that gives me 4. So I have another prime number. Can 4 be divided by 2? Yes, it can, gives me 2. So now every number at the end of those branches are prime numbers. So we are only looking at the numbers at the end of the branches. We are no longer looking at any of these numbers that are inside to simplify, okay? So now we're looking for, do I have any pairs of numbers? I have a pair of 2s and another pair of 2s. So that means for the square root of 16, this pair of 2s over here gives me 1, 2. This pair of 2s over here gives me another 2. And those are going to be multiplied together. So 2 times 2 gives me 4. And if you check on your calculator, the square root of 16 is 4, and that's why, okay? Let's look at number 2. Square root of 36. Can 36 be divided by 2? Yes, it can, and that gives us 18. Can 18 be divided by 2? Yes, it can. That gives me 9. 2 is prime, so I'm going to highlight those two 2s. Can 9 be divided by 2? No. So then we move on to the next number in our list, which is 3. Can 9 be divided by 3? Yes, and that gives me 3. These are both prime, so we are done with that. Again, we are not looking at any of the numbers inside the tree. We are only looking at the numbers at the ends of the branches here. So I have a pair of 2s here, which means I will have 1, 2 outside the square root. I also have a pair of 3s, which means I have a 3 outside the square root as well. Again, those are multiplied, so 2 times 3 is 6. And again, if you check on your calculator, square root of 36 is 6. Number 3, we have 144. So we start with our first prime. So is 144 divisible by 2? Yes, that gives us 72. So that's a prime. Is 72 divisible by 2? Yes, it gives me 36. So this is a prime. And then 36 we broke down up top in that last problem. We had 2 and 18, 2 and 9, and 3 and 3. And then these are all primes as well. Once we have those primes, we look to see what pairs we have. I have a pair of 2s here, so I get 1, 2 outside. A pair of 2s here gives me another 2. And then a pair of 3s gives me a 3. 2 times 2 is 4. 4 times 3 is 12. And same thing, check on your calculator. The square root of 144 is 12. Number 4, square root of 75. We start with those lists again, that list of prime numbers. Can 75 be divided by 2? No. So we move on to 3. Can 75 be divided by 3? Yes, that gives me 25. Here's our first prime number. Now we're working off 25. Can 25 be divided by 2? No. Can it be divided by 3? No. Can it be divided by 5? Yes. And that gives me 5 and 5. So we have all of our prime numbers at the end. So now again, we're looking for pairs of numbers. The only pair of numbers I have is 5. So that means I have a 5 outside the square root. And I have a 3. This 3 does not have a pair. So that means it has to stay inside that square root by itself. Okay, remember we are not using any of the numbers inside. We are only using the numbers at the end. So we get 1 5 outside the square root from that pair. This 3 does not have a pair, so it has to stay inside the square root. So the square root of 75 simplifies to 5 square root of 3. Okay, that is how we would leave our answer. As we looked at number 5, we said that couldn't be simplified, so that stays square root of 30. Number 6, we're looking at 108. Can 108 be divided by 2? Yes, that gives me 54. 54 is divisible by 2, and that gives me 27. 27 cannot be divided by 2, so we look at 3, which gives us 9. And then 9 is 3 and 3 as well. So we have all of these numbers at the end of my branches. We have a pair of 2's here. So I get a 2 outside the square root. I have a pair of 3's. That gives me a 3 outside the square root. And I have 1 3 left over that has to stay inside. Okay? So the 2 and 3 that I pulled out can be multiplied. So 2 times 3 gives me 6. And then we still have that root 3 at the end. So the square root of 108 simplifies to 6 square root 3. If we look at 7, we have 49. 49 is not divisible by 2 or 3 or 5, but it is divisible by 7. And that just gives me 7 and 7. There's my pair. So the square root of 49 is 7. Again, you can check that on your calculator. Your calculator will not give you these simplified square roots as, like it won't give you the simplified version, but I will show you what you can do to make sure that you have simplified them correctly. If we look at that last problem, square root of 108, we get this really long decimal, 10.39, blah, blah, blah. We simplified that to be 6 square root of 3. So these should give me the same thing because they are simplified. 6 root 3 is simplified of 108. And we do. We get that same decimal, so we can see that these are the equivalent. We have simplified properly. Okay, so make sure you're doing this to make sure that you're getting the correct answer. They should give you the same decimal. And then, of course, like the square root of 49, you can just plug that into your calculator. You should see 7 because that is a whole number. So you only need to check the original and simplified if it gives you a decimal and does not simplify to one whole number. And then our last one, 150. 150 is divisible by 2, and that gives me 75. 75 is divisible by 3, which gives me 25, and 25 splits into 5 and 5. So we have all of our prime numbers at the end here. We have one pair of 5s, so that's going to come outside the square root. We do not have a pair of 2's, so that 2 needs to stay inside. We also do not have a pair of 3's, so that also needs to stay inside. Again, those are multiplied. So no matter if they're inside or outside the square root, they are multiplied. So we would have 5 square root of 2 times 3, which is 6. Okay? And again, you can check these on your calculator. Type in square root of 150, and 5 root 6, and you should get the same thing. When you're finished here, go on and go to the next page. So this is like what we were doing the other day. So we want to isolate whatever is being squared. So in this problem, the p is being squared, so that needs to be by itself, which it already is. So to solve, we can square root, okay? And when we square root, we get the positive and the negative, okay, which is what we talked about before. So we could have p equals the square root of 4 is 2, but then we also get negative 2. So we want to make sure we're including the positive and the negative. Number 2, we have our x is the only thing being squared, so that is already isolated. So we can square root both sides. Square root of 49 is 7, and we have negative 7. If we look at number 3, the x is the only thing being squared, so we need to make sure we get that alone first. So I'm going to add 1, so x squared equals 51, and then we can square root both sides. Square root of x squared is x. 51 does not have a nice square root. It gives us a decimal, so we need to break that down. So first we can see, is 51 divisible by 2? No, it's not. Is it divisible by 3? Yes, and that gives us 17. But then 17 is not divisible by anything. So we now have 2 prime numbers at the edge of these branches here, and because I don't have a pair of anything, I can't take anything out. So that means the square root of 51 cannot be simplified. So what we're going to say for our answer is x equals the square root of 51 and the negative square root of 51. So we have to keep, again, both signs. We just can't simplify that square root. Number 4, again, the only thing being squared is v, so we have to get that by itself first, which means I'm going to add the 8. So v squared equals negative 7 plus 8 is 1. And then we can square root. So the square root of 1 is just 1. So v equals 1 or negative 1, listing both the positive and the negative. Number 5, the only thing that's being squared is x. So we can first get rid of the 10 by subtracting 10 to both sides. And we have x squared equals 65. And then we can take the square root. 65 does not have a nice number when you square root it. We get a decimal. So we have to simplify it. So can it be divided by 2? No. Can it be divided by 3? No. So we check 5. 65 divided by 5 is 13. Okay, but then 13 is also prime. So again, these cannot be simplified any further. I do not have any pairs of numbers. So x equals square root of 65 and negative square root of 65. Number 6, the only thing that's being squared is the x, so we have to get rid of the 4. So we can divide by 4 because it's being multiplied. X squared equals 3, and then we square root, okay? The only way 3 can be broken down is with 3 and 1, right? And 3 is already a prime number because it was in our list of prime numbers. So we can't do anything further with that. So x equals root 3 and negative square root of 3. So those are our 2 answers there. Then we have number 7. R is the only thing being squared, so we have to get rid of everything else first. So we're going to add 5. Add 5. So we have negative 5r squared equals negative 180. Then we can divide by negative 5. So we have r squared equals 36. And now we can take the square root. So we get r equals, the square root of 36 is 6. So we have 6 and negative 6. For number 8, k is being squared. So we can first get rid of 4 by subtracting 4 from both sides. So I have 7k squared equals 448. And then we can divide by 7. K squared equals 64. And then we can square root both sides. And the square root of 64 is 8. So k equals 8 and negative 8. And those are my two answers. Number 9, m is being squared. So we can first move the 5 by subtracting 5. So we have negative 8m squared equals negative 576. Then we can divide by negative 8. And we have m squared equals 72. Then we can square root both sides. So we have just m on the left. The 72, though, we have to break down. So we can first see if 72 is divisible by 2, which it is. That gives us 36. That's divisible by 2 to give us 18. That's divisible by 2 to give us 9. And then 9 breaks down to 3 and 3. So again, we are looking at just our prime numbers at the ends here. And we're looking for pairs. So I have a pair of 3s and a pair of 2s and then 1, 2 that's alone. So 72 would break down into 2 from the pair of 2s times 3 from the pair of 3s, root 2 from the 1, 2 left over by itself. And then we can multiply 2 times 3 together. That gives us 6. So over here, the square root cancels with the square for our variable. So we would say m equals 6 root 2 and the negative of that as well. So those would be our two answers for this question. And then our last one here, k is being squared. So we will need to subtract that 10 first. So we have negative 3k squared equals negative 147. Then we can divide by negative 3. Oops. K squared equals 49. And we can now square root, and the square root of 49 is 7. So k equals 7 and negative 7. Okay, so again, please write down if you have any questions, and then you can start on your practice.